TIG welding, also known as gas tungsten arc welding, GTAW, is widely used in gas plants across America due to its precision, cleanliness, and ability to produce high-quality welds on a variety of metals. In an American gas plant, TIG welding is typically employed for critical components that require strong, clean, and defect-free joints. These plants handle hazardous and high-pressure gases like natural gas, hydrogen, oxygen, and liquefied petroleum gas, LPG, making the integrity of every weld essential for safety and performance. TIG welding is ideal in this context because it allows for meticulous control over the heat and filler material, producing clean welds with minimal spatter or slag. In gas plants, TIG welding is frequently used on stainless steel, aluminum, and high-alloy steels, which are common materials for piping systems, pressure vessels, control panels, and structural components exposed to corrosive environments. These materials often require high-purity welds without contamination, which TIG welding provides by using a non-consumable tungsten electrode and an inert gas shield, typically argon or a mixture of argon and helium. This shielding gas protects the molten weld pool from atmospheric elements like nitrogen and oxygen, preventing oxidation and ensuring a strong, corrosion-resistant joint. Because gas plants often deal with high-purity gases or cryogenic liquids, welds must pass rigorous inspection and testing, such as X-ray, ultrasonic, and dye-penetrant tests, to ensure leak-proof performance under extreme pressure and temperature. In many American gas plants, TIG welding is used for both fabrication and maintenance tasks. During construction phases, skilled TIG welders join precision pipe sections, valve assemblies, and compressor units where dimensional accuracy and metallurgical quality are paramount. These tasks often involve intricate welding in tight spaces or on complex geometries. Because TIG welding allows for welding in all positions, horizontal, vertical, overhead, and flat, welders can perform delicate operations in confined plant environments. The slow, deliberate pace of TIG welding is seen as a benefit in these situations, where quality takes precedence over speed. Although TIG welding is slower than other methods like SMAW or MIG, its precision makes it indispensable for joining thin-walled tubing and intricate joints commonly found in instrumentation and control systems within the plant. TIG welding is also heavily involved in repair and retrofit operations in American gas plants. Equipment like heat exchangers, flare stacks, pressure piping, and gas cylinders often experience wear over time due to corrosion, high heat, and vibration. TIG welding enables technicians to repair these components without introducing impurities or structural weaknesses. Since many gas plants in the U.S. operate under strict codes such as ASME Section 9 and API 1104, all weld repairs must meet exacting standards. TIG welders.